Edwin Hubble, from whom the Hubble Space Telescope is named, was one of the leading astronomers of the 20th century. In the 1920s, he discovered that countless galaxies exist beyond our own Milky Way galaxy, and even created a system for classifying them into ellipticals, spiral, and barrel spirals. Later, as the 1920s came to an end, he discovered that galaxies move faster apart the further the distance between them. From this, he concluded that the universe had to be expanding uniformly. Others had posed this theory based on Einstein's general relativity, but Hubble's data helped convince the scientific community. The Hubble Space Telescope was launched in 1990 and was the first telescope to be orbiting the Earth. Because of its unique position, the Hubble Telescope is unaffected by the atmosphere, which blocks and distorts light that reaches our planet. In turn, this means the Hubble telescope, although smaller, typically takes far better pictures than those on Earth. The power of telescopes lies not in their ability to magnify, but by collecting more light than the human eye is capable of. The Hubble telescope is the type of telescope known as Cassegrain reflector. This means it works by light hitting the primary mirror, which is a concave mirror, and then reflected onto a specific point where a secondary mirror is located. The secondary mirror then reflects light into a small hole in the center of the primary mirror, where all the telescope's recording equipment is located.
One of the uses of the Hubble Space Telescope has been the detection of what appears to be the most distant and earliest galaxy yet discovered. This is a galaxy that was formed 480 million years after the start of the universe, with its light having to travel 13.2 billion years to get to us. In 2009, scientists observed a patch of sky known as the Hubble Ultra Deep Field, using the telescope's new Wide Field Camera 3, which is extremely sensitive to infrared light. Hubble exploits the redshift that the light emitted from the galaxies are subjected to, which happens because the galaxies are moving away from us in the expanding universe. From the resulting observations, a haven of new stars and galaxies were discovered, and with this data, scientists contemplate that between the time of the formation of the oldest galaxy and the second oldest galaxy, the birth rate of stars increased exponentially. This gives credibility to the theory that the first stars were formed around 200 to 300 million years after the Big Bang. But astronomers are unsure if the number of stars that have been observed are enough to account for the amount of high-energy radiation needed to ionize the hydrogen atoms that light as a dark fog covering the entire universe. It has been suggested that the high-energy particles whipped around by black holes could have played a part in clearing this fog. However, more data is needed to confirm either theory, which we'll hopefully get when the James Webb Telescope launches later this decade.